Illustrate with examples the limitation of Williamson's synthesis for the preparation of ethers. Well, when you actually carry out Williamson's synthesis, please understand that the mechanism is SN2 mechanism. So all the reactions for which SN2 mechanism does not work very nicely would be the cases in this question. What do I mean? I'll just exemplify with some cases, like say for example. Now first let me write down what is Williamson's synthesis and then we can talk about the limitations. If I have a case in which RO minus alkoxide ions react with alkyl halide, well, there's a lovely backside attack, classical SN2 reaction, and I get RO R dash plus Cl minus. This is the method, the Williamson's synthesis method to obtain ethers. Okay, fine. Now, which are the cases which won't work? Do I have any constraint on RO minus? Actually none. It could be just anything. Alkyl group could be primary, secondary or tertiary. It could be present even at a bridgehead position. It could be aryl group, benzene ring, whatever. There is no constraint. It can be absolutely anything, as long as it is an alkyl group. This presents a problem. What? Why? See, R dash has to be primary. Best is if it is primary. Even if it is secondary, it's okay. But R dash can never be tertiary. R dash can never be vinylic. It can never be phenylic. Why? Why these constraints? Let me give you 3 examples. They're asking about limitations of Williamson synthesis. So the limitations are the limitations as prescribed by SN2 mechanism. The first limitation is R dash Cl cannot be, in R dash Cl, R dash cannot be. R dash cannot be tertiary. Why? In case of tertiary, a substitution doesn't happen. Unfortunately, an elimination would occur. E2 elimination dominates in the case of tertiary. There is a reason why we can't use tertiary. What do you mean? We don't understand. I'll give you an example. Take a look. Say we have CH3, O minus. I'm just keeping it simple. And say we have CH3, C, Cl, CH3, CH3. So first of all, in tertiary, there's too much of steric crowding. For an SN2 attack, this attack has to happen at this location. I'll just show you. It has to come here. This is very light. Yes, it is light by design because this doesn't happen. It is a difficult reaction. On the other hand, much simpler is if it takes away this H plus. Oh my God, what happens? This happens. CH3, OH, it has taken away H plus. This CH2 group now forms an alkene. It has pushed away, Cl minus has pushed. It has no respect. It is always kicked out. But in which style? This is not SN2, it is E2. And unfortunately, you don't get an ether, you get an alkene as the major product. So, R dash cannot be tertiary. Why? Because if you use tertiary alkyl halide, you would get alkene as the major product and never an ether. Reason being, steric crowding around tertiary carbon atom does not allow an easy approach of nucleophile on tertiary carbon. This is the first limitation. Is there a second limitation? Yes. Vinyl halides do not give Williamson's synthesis. I have a limitation of space. I'm not writing down the grammar sentences. But vinyl halides do not give Williamson's synthesis. What does that mean? It means that if I have CH3O minus and if I have CH2 double bond CHCl like this, and if I try to react them, actually nothing happens. There is no reaction. They just don't react. Why? Why? Because this bond is very, very strong. Stronger bond by sp2 carbon. This carbon atom is sp2 hybridized. This bond is stronger. Not only this, these lone pairs are in conjugation with this pi bond, making this sigma bond even stronger by some pi contribution. So since leaving group is no longer a good leaving group, why? Because the bond formation is stronger. Nothing happens. It just doesn't leave. It refuses. In the same fashion, the third point, aryl halides do not undergo Williamson's synthesis. CH3, O minus once again, plus say you have chlorobenzene. Again, this bond is stronger. It doesn't break. And there has to be a backside attack in a SN2 mechanism. And for backside attack, you can't break through benzene ring and you can't destroy the ring and just attack from the backside. It is just not possible. What happens? Nothing happens. There is no reaction. Vinyl and aryl halides fail to react, while tertiary halides produce an alkene. These are the three classic cases where Williamson synthesis cannot be done.